Hello everyone. Welcome back to Let's Crack JEE in English, the channel of Unacademy, and I'm Jeetendra Dixit. Before we begin, let me just check my voice. One moment. Hello Jia, good afternoon. Are you getting my voice? Okay, yeah, it seems good. So, okay. So before we begin, let me just tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and if you're preparing for IIT-JEE, then you can subscribe for you can take plus subscription or iconic subscription. In plus subscription, you get access to daily live classes of all the educators who are teaching on Unacademy. You can follow educator of your choice, you can follow their course, and you can watch their live sessions as well as recorded sessions also. You can download recorded sessions and watch them offline or as well. Live tests and quizzes will also be accessible, and all the courses are well structured. So this is the unlimited access which you get on Unacademy's platform. These are the subscription charges. So you can subscribe for 1 month, 3 months, 6 months, 12 and 24 months. 12 and 24 months subscription charges are 38,500 and 56,000, and you get 10% discount as well. You can use the referral code JEET1. Okay, in this you will get 10% instant discount. Now the second is iconic subscription. In iconic subscription, you get all the benefits of plus, and apart from that, you get a personal coach who will guide you throughout your preparation for top exams, and your test analysis will be done in a personalized manner. Your personalized feedback will be given to you, improving your time management, to improve your time management and exam approach. Your study planner will be customized, bi-weekly reviews will be given highlighting your progress. So these are the benefits of iconic subscription. Now, this is the price list for iconic subscription. You can subscribe for 6 months, 12 and 24 months. 38,000, 65,000 and 1 lakh. And in all these packages, you'll get 10% discount as well using the same code JEET1. And this is Unacademy's learning app which you can download from Play Store, and after downloading, you can start your uh, free content, free special classes you can attend using the same referral code JEET1. You can access that free content. All right. So this was the information about Unacademy's classes, subscriptions, and free content. And one more information about next combat, which is on 20th of December. 20th of December, there's next combat, IIT-JEE combat, gamified form of exam, and you can win a lot of prizes in that. So enroll in that, and you can use the same code JEET1 for that also. All right. Now we are starting today's session of straight lines, pair of straight lines. So we were doing general equation, all right. So let's relate. Here we were doing shifting, okay? Have you got that? Shifting, wala point. Shifting of curve, okay? Shifting of curve. Shifting of curve, x is replaced by x minus h, and y is replaced by y minus k. Do you remember that? If curve is shifted, if curve, I'm writing it here, curve is shifted to h comma k with respect to origin, okay? With respect to origin. That means horizontally translated by h units and vertically translated by k units, okay? The complete curve. Then its equation f of x comma y will change to f of x comma y is equal to 0 will change to f of x minus h comma y minus k if curve is shifted, not origin. Okay, in case of origin, you know, it is x plus h and y plus k. So curve is shifted. Yes, when origin is shifted, so that means curve is shifted to minus h minus k. So it will be x plus h and y plus k. It's a relative motion basically, right? When curve is moving, origin is staying at its original position. Then curve is going in this direction, like say in first quadrant. When origin is going in first quadrant at some point h comma k, then that means curve, if you consider that origin is constant, origin is not moving, then curve is going in opposite direction, okay, at minus h comma minus k. It's like that. It's like relative motion. All right, so now let's apply this. So now we have equation of pair of straight lines. Okay, so we are now trying to understand the general equation of straight lines. Okay, general equation. This was the homogeneous equation, ax square plus 2hxy plus by square is equal to 0. This represents two straight lines passing through origin, and this equation is called 2-degree homogeneous equation, right? Now this curve is shifted to some point, say x1 comma y1. Okay, so this point is x1 comma y1. So this line will become like this, and the second line will come like this. So lines are parallel, right? This first line, this is third line. Okay, first and third are parallel, second and fourth are parallel, right? You can see that. I have not rotated the curve, I have just translated, okay, keeping them parallel. So first thing you need to understand is that slopes of lines will remain same. If this line was y is equal to m1x, then this line will be y is equal to m1x plus c1. The only difference is of constant. If this line is y is equal to m2x, then this will be y is equal to m2x plus c2. Are you understanding this? Now what will be the combined equation? Then combined equation of, let's write the combined equation using the shifting we have learned. Okay, so combined equation of 3 and 4. Combined equation of lines 3 and 4. That means shifted curve is given by, okay, so what will it be? A times of x minus x1 square plus 2h x minus x1 into y minus y1 plus b times of y minus y1 square. All right, this is the equation of shifted curve. All right, this represents the third and fourth line. So now I am going to open it. If I'll open it, I'll get this term, see ax square, the same x square wala term which was there in the equation number, say this is equation number a. Okay, so ax square plus 2hxy, see this 2hxy plus by square. So I have written the 2-degree terms first. So the 2-degree terms will remain same which were in the original equation. In the original equation, 2-degree terms were ax square plus 2hxy plus by square. In this general equation, also 2-degree terms will remain same. You can see that. If you expand it, then 2-degree terms are coming out to be same. Okay, I hope you are getting it. Now I am writing the additional terms I am getting in this equation. So additional term I am writing now. So first let's write the terms which have x raised to 1 power. So from this you'll get minus 2ax1 minus 2ax1 into x. Okay. From this also you'll get 2hx into y1. So minus 2hy1, and here you won't get any term of x1. So this is this whole into x, all right? Plus, now let's write the term of y. So you're not getting any term of y here. Here you'll get the term of y 2h into x1 into y, right? Yeah. So minus 2h x1, and here also you'll get b into minus 2y1y, so minus 2y1b into y, plus the constant term. Are you understanding the calculation? Plus the constant term. Constant term you'll get ax1 square in the first term, ax1 square plus 2hx1 y1 in the second term, and plus by1 square in the third term. All right. So this is the kind of equation we are getting. All right. This is the kind of equation we are getting. I am writing this equation in some new form. What is that new form? Let's see. I'm calling this equation B, okay? Let's use this equation in the next page. So this equation B is ax square plus 2hxy plus by square plus what was that? Minus 2ax1 minus 2hy1 minus 2ax1 minus 2hy1 into x plus minus 2hx1 minus 2y1b. All right, into y plus ax1 square plus by1 square plus 2hx1 y1. Okay, this was the equation. This is equation B, and what I'm doing is I'm taking these terms, these terms as this term as 2g, this term as 2f, and this term as c constant. Okay, this I'm taking as 2g, this I'm taking as 2f, some new variable 2g, like I have written 2h here, coefficient of xy. Similarly, coefficient of x I'm taking 2g. You can take like x, y, z, anything. You can take any parameter like a, b, h. We are already going to take c, d, e, f. In its standard form, you take 2g because g is used in many formulae. If you take g, then it will be g by 2 in those formulae. So to make all these formulae, easily we need to write 2g, coefficient of x. So after writing it, we can write the general equation in this form: ax square plus 2hxy plus by square plus, now listen to this, 2gx plus 2fy plus c is equal to 0. So in this form, we remember it. Now I'm going to relate this. I'm going to tell you a lot of information about this equation. Okay, this represents a pair of straight lines 3 and 4. Okay, pair of 3 and 4. See this, 3 and 4. Okay, but the same equation can represent a circle also, can a parabola also, can ellipse also, can hyperbola also. So there will be some condition, okay, for this general equation to represent a line. If we are shifting the 2-degree homogeneous equation at h comma k with respect to origin, then this equation, 2-degree homogeneous equation, will transformed into this form: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. All right, this is 2-degree homogeneous. This is called 2-degree general equation. First of all, let's see what is the point of intersection, because in 2-degree homogeneous equation, we know the point of intersection is represented by origin, but in this case, what will be the point of intersection? So can you compare what was 2g? So minus 2ax1 minus 2h minus 2hy1. This was taken as 2g, right? Can you see that? So that means this is nothing but this can be written as 2, you can cancel, you can write ax1 plus hy1 plus g is equal to 0. All right, this is a relation in what is the relation between x1 and y1? What is x1 and y1? X1 and y1 is the point of intersection of the lines represented by this equation C. Similarly, the other relation, second, we need two relations, right? So minus 2hx1 minus 2y1b is equal to 2f. So from this we'll get hx1, okay, I'll write with white color, hx1 plus by1 plus f is equal to 0. All right, so if you solve these two relations, this is relation number 5 and 6. Solve 5 and 6 to get the point of intersection. X1 comma y1. X1 y1 is the point of intersection, right? We know that because we have shifted the original equation to x1 at x1 comma y1, right, with respect to origin. So the point of intersection x1 y1 of lines given by C. All right, that is a very beautiful theory. Now I'm going to tell you some points, important points. First, you just have a look and tell me if there is any doubt. Just a moment here. Give me 2 minutes. Give me 2 minutes. I'm changing the network. Okay, so there's some problem. I'm restarting. All right. I hope you're getting my voice. Hi, are you getting my voice now? Hello? Are you getting my voice? Hello, Gia. All right. See this equation. I'm calling this equation as S. this expression actually, this one, okay? This expression I'm calling Sxy, okay? I'm just naming it as like function of x and y. Generally, 2-degree curve is represented by S, okay? So I'm simultaneously writing xy just to represent that it's a function of x and y, okay? So this whole expression, writing it again and again, I'm writing x, s, x and y, all right? I think it's all right. See, how would you remember if he is asking, suppose this equation is giving and you know that it is representing a pair of straight lines, you know it, okay? Suppose you know it. I'll tell you the condition later after this. I'll tell you the condition when will this equation represent a pair of straight lines. But now let's assuming that C represents a pair of straight lines, okay? And if it represents a pair of straight lines, then there will be a point of intersection also, which will be given by these two equations, right? Which will be given by these two equations. All right. So either you remember equation number 5 or 6, or there should be another way of memorizing these fifth or sixth equation. So I'm telling you another way of memorizing equation number 5 and equation number 6. So if to find the center, to find the point of intersection, to find the point of intersection. Okay, all right, let's write on the next page. To find the point of intersection of lines given by Sxy is equal to 0, where Sxy is equal to ax square plus 2hxy plus by square plus 2gx plus 2fy. Now you need to remember this whole expression. Solve. किसको solve करना है? See this. Partially differentiate this curve with respect to x. You know what does it mean, differentiating partially? That means you are differentiating with respect to x, all right, keeping y constant. So differentiate this expression, this one, with respect to x. If you differentiate it, you'll get 2ax. If you differentiate this term, then 2hy is a constant. You are differentiating with respect to x. Y is a constant. Y will not be written as dy by dx, okay? Y is a constant when you are doing a partial differentiation, all right? When you differentiate some expression which is of x, y or z or t, or no matter how many variables you will take, if you are differentiating with respect to x partially, that means all the other variables will be treated as independent variables, okay, with respect to x, independent variables. So have you got the meaning of partial differentiation? So now 2hxy, if you differentiate 2hxy, what will be the term if you differentiate 2hxy with respect to x? Can you tell me what will be the term if you differentiate 2hxy? It is going to be 2hy, right? 2hy. And then differentiation of by square will be 0 because there's no x. Then differentiation of 2gx will be 2g. 2fy will be 0 and differentiation of c will be 0. So this is the equation. So you'll get this. You'll get ax plus hy plus, this last term was 2g, sorry, 2g. Okay, it was right actually. 2g. So plus g is equal to 0, right? This is the first relation. The next x and y is a center. Okay, you need to solve equation number 1 and partially differentiate s xy with respect to y. So if you differentiate with respect to y, I'll get this. First term will be 0. Second term will be 2hx plus next term will be 2by. Yes. The next term will be 2gx will be 0. 2fy का differentiation will be 2f plus 0 is equal to 0. So you'll get this equation hx plus by plus f is equal to 0. So this is a way to remember it. If you solve 1 and 2, solve 1 and 2 to get the point of intersection. Oh, but we knew these equations. Where? We have just learned. We have just learned these equations. We have just seen the derivation of these two equations in the previous slide. Can you see these two equations? Equation number 5 and 6. ax1 hy1 plus g. ax plus hy plus g. Can you see this? Equation number 1. Equation number 5. ax1 hy1 plus g. ax plus hy plus g. Now see equation number 2. hx plus by plus f. See equation number 6. hx1 by plus f. Are these two equations same? 5 and 6 and 1 and 2 on next page. Can you see that? These two, equation number 5 and 6 and these two. So actually equation number 5 and 6 I have written it again, and I have told you a way to remember it. The 2 degree, because in this form you memorizing this is a difficult task, but in this way differentiating this 2 degree general equation, because we are going to remember 2 degree general equation. Okay, so we can differentiate 2 degree general equation with respect to x. We'll get equation number 5, this equation number 5. How would we get equation number 5? By differentiating 2 degree general equation partially with respect to x. We'll get equation number 5. And differentiating 2 degree general equation with respect to y, will get equation number 6. And we know that these two equations, if we solve these two equations, the values of x and y are basically the values of points of intersection. All right. So yes, so this is a way to memorize it. You need to solve these two equations, which I am writing inside the box. Okay. Okay. Solve these two. In fact, in any 2 degree curve, circle, ellipse, and hyperbola, these two equations, if you solve these two equations, del by del x s of xy, del by del y s of xy, that means these two linear equations, ax plus hy plus g and hx plus by plus f, you will get the center of the curve. Center of the curve. In pair of straight lines, it will be point of intersection, but in case of circle, in case of hyperbola, in case of ellipse, because the same 2 degree equation will represent ellipse, hyperbola, parabola, and circles also. The same 2 degree equation is going to represent all 3 curves as well, right? All remaining conics. But parabola, in parabola there is no center, so in parabola you won't get any center. Okay, these two lines will become parallel, so you won't be able to solve them. But in any other curve like circle, ellipse, and hyperbola, what will you get by solving these two equations? Center of those curves, center. So this is the method to find the center of the curve when 2 degree general equation is given. All right, have you got this point now? I guess this is very, very important. These two relations, del y by del x and del y by del y, are very important relations, and I have also told you the proof relating it to shifting the standard curve. Standard means whose center or maybe point of intersection was at origin. If we shift that curve, we'll get general equation, and then in general equation we can compare the center or point of intersection in case of straight lines, and we'll get this relation del by del x and del by del y. All right, so I hope now it is clear. Okay, so all right, wait a minute. Wait a minute. So actually, you'll see you won't get this proof in most of the books because they generally write this directly, del by del x and del y, to write to get the center or to get the point of intersection. So students just memorize it. But using shifting, I have just tried to relate it that you should know the logic also. Just a moment, I'm trying to give you one question. Find the centers of the curve. Sorry, find the point of intersection. Use this formula and let me know the point of intersection. Find the point of intersection. Find the point of intersection of lines represented by 12x square plus 7xy plus minus 12y square minus 12y square minus 17x minus 31y minus 7 is equal to 0. Okay, so find the point of intersection of the lines represented by these two equations. Try this one. Use that formula. Use that formula, Gia. Are you getting the point, Jia? Is it difficult? Oh, I was waiting for your answer. I have given you one question to find the point of intersection of the lines represented by this equation. I thought you were solving it. We need to find the point of intersection of this is the equation representing two lines it is given. You need to find the point of intersection of the lines represented by these two. All right. Are you solving it now, Jia? Okay, I'll solve it then. First, we'll differentiate this equation with respect to x. So if you differentiate, what will you get? You solve it. You solve it. If you get the point, just let me know. This is 24x plus 7y minus 17x is equal to 0. If you solve this equation with respect to, if you differentiate this equation with respect to y partially, you will get 7y 7x, I'm sorry, 7x plus 7x minus 24y, okay, and minus 31 is equal to 0. This x will not be there. Now you need to solve these two equations. So let's multiply this equation by 7. This equation by 7 and this equation by 24. Wait a minute. No. The first equation by 24 and the second equation by 7. Okay. We can cancel y in that way and add them. So if you add them, this term will get cancelled and you'll get 24 square minus 7 is 24 square plus 7 square into x is equal to 17 into 24 plus 31 into 7. Let's calculate this. So these are big numbers. into 24 plus 31 into 7. This is 625 and I think this is also 625. 24 square and plus 49. Yeah, this is also 625. So this will get cancelled and x is equal to 1. So you'll get x is equal to 1. If you put x is equal to 1 in any one of the equation, put in this. So x is equal to 1 and y is equal to, put in this. So this will give you 24 plus 7y minus 17 is equal to 0. So this is basically 7 plus 7y is equal to 0. So y is equal to minus 1. So y is equal to minus 1. Now you got the method to find the point of intersection of the lines represented by the curve, right? All right. Now one more point. The one more point is this. Uh, so actually, I'll have to end the meeting a little early today. I have a lot of points to discuss in this pair of straight lines. So I thought I would be able to finish it today, but no, it's not possible because uh, yeah, there are a lot of points are there. It will take 1 hour at least, and more, maybe more than that. And homogenization is also there, so I've already planned a session for homogenization. Maybe I'll have to plan another session for straight lines. So okay, I'll continue tomorrow. Okay, continue tomorrow. All right, Jia. Okay. All right then.